Right, okay, resistance. So we've talked about two things in terms of electricity. Take the bottle off of this. Two things we've talked about in terms of electricity. So I've said to you, don't use the word electricity anymore. Get these other two words you have to start using instead. Okay, so what were those other two words that we start using instead? Okay, Ben, give me one.
AC and DC.
AC and DC. AC and DC refer to alternating and direct what? Sorry? Just kind of cough there and stop. It starts with a C. Yes, I'm asking you. Current. Okay, so we've had current, which is what? What is current? Jack? Current is the flow. Flow of water? Darryl?
Flow of negatively charged particles through
You just stop while you're ahead. Okay, the flow of negatively charged particles through a conductor, through a metal or whatever else conduct through a wire. So the current is the flow of negatively charged particles. What's the other word that we have now learned? Katie? Did it last day? You want to note in a jotter? Voltage. So we had voltage, which is what? What is voltage then? Connie?
the amount of energy that's the electricity actually has.
Right, well, it's the amount of electricity has. If it's not quite the electricity, voltage is electricity. So current and voltage are electricity. So it's not about how much energy the electricity has, it's certainly how much energy something has. If current is the flow of negatively charged particles, then the voltage is how much energy these charged particles have as they fly through the circuit. So voltage is like a measure of energy, current is a measure of flow, and together they give us electricity. Now the third thing to think about is resistance. Now if I said the word resistance to you, or how resistant you are to something, what does that mean? Someone's resistant, Ross. If I'm going to resist you, or I can't resist you, what does that mean?
You can't
Can't slow down. Right, so let's start a few rumours. Let's say Lizzie and Jack. Lizzie cannot resist Jack. His charms, his electric personality, even the wrist brace really attracts her to him. So if Lizzie cannot resist Jack, what does that mean? What does that mean? Was that what? Can't keep away from. She can't keep away from him. She can't. Okay, she finds it hard to resist. So hard to resist means she can't keep away from him. So does she have? Now you would say if she can't resist him, she doesn't have any resistance to him. That means she finds it very easy. She really wants to go towards him.
Is resistance pushing against?
Something, right? So let's just turn around what I've just said there. She can't resist him. She must be close to him. If she feels like he's resisting her, what does that mean, Lizzie? Do you feel like Jack is resisting you? Resisting your advances. What does that mean?
It means like it doesn't want to be with you.
Doesn't want to be with you. Can you go?
Yeah.
Jack doesn't want to be with you. If he's resisting your advances, if he's resisting you, he's making it difficult for you to have a relationship. Okay? He's resisting you. If the resistance is high, then he's trying to stop you. He can't actually stop you because you're your own person. You can walk up and you can be with him if you want to be. You can have your way with him if you want to be, but he can't. But he resists it. You can't stop it, but he resists it. Right? There's not a force field around Jack stopping girls coming near him. However, he resists the advances of people he doesn't like, such as Lizzie. I'm not saying you don't, just say you do. Okay, so let's start another one. Darryl and let's go to Darryl right well. Let's do a heterosexual couple. Okay. Darryl and Katie. Right? Katie can't resist that. She wants to be with him so bad. But Darryl feels like he wants to resist Katie. So he can't stop her. Like she can come up and give him a cuddle, but he can't stop her, but he doesn't like it and he tries to stop it. He tries, but he can't do it. So resistance means you can try, but you can't actually stop it. You can slow it down, you can try and hold it back, you can't stop it. resistance in an electronic circuit is resisting the flow of charge, resisting the current flowing through it. Can't actually stop it, but it can try and slow it down. Okay, it can say, whoa, 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 I'm not ready for that. Okay, slow down. Take it easy, one stage at a time. Okay? So, resistance is resisting the flow of charge. A component which resists the flow of charge. Okay? So, a resistor, in fact not a resistor, let's say resistance.
You copying this down, sir?
Yeah, I'll just rub that out, just copy down from here. Alright? So let's copy down here. Heading is resistance. Okay, so this is how much something in a circuit tries to slow down the flow of current. Resistance are electrical components which slow down the flow of charge. Now we're going to do electrical components next week. Now, Ohm's law, one of the most famous formulas that were ever given in physics, and it looks like this: V equals IR. Just a very simple formula, where V is our voltage, and voltage is measured in volts, and the units for that are large V. I is current, measured in amperes or amps, symbol large A. Resistance is symbol R, and it's measured in ohms, OHMS. And here's the symbol. The symbol is like a funny horseshoe. It's a large omega, which looks like that. Okay, that's the symbol. So it could be 10 omega, would be 10 ohms. Okay? So this is Ohm's law. Now you already have the charge formula as well, which was Q equals IT as well. And between these two formulas, these are the two formulas we need to try and work out charge, current and voltage in different components. Alright? So today we're going to look at answering some of our, finish off on our charge, current and time questions. I won't get to do them all, I'll pick some for you to do. And then we're going to have a look at the voltage, current and resistance formulas. Okay? And the next day, as I said, we'll get the electronic boards out and we'll start doing circuit components. What the circuit components are, how we build the circuits, how they interact with one another, and resistance will make a lot more sense if you're still a wee bit confused just now.